Hello, my dear young friends. How are you? I hope you all fine and facing your exams very nice. So once again, all the best for all the students. So in this video, I would like to explain average kinetic energy and average potential energy in case of simple harmonic motion. Right? What is meant by average of for a given physical quantity? Suppose y equal to f of t is any function. Now, what is the average of point y, that is point average of given point y equal to integral y dt divided by integral dt in a given time interval. So this is what expressed for average for any given quantity. So average of y equal integral y dt by integral dt under limits, for example, within a time interval, for example 0 to t or 0 to t, right? So this also can be written as integral 0 to t y dt. What is y? F of t. So f of t dt divided by integral 0 to t dt, right? So for example, as an example, we know very well what is meant by electric current, the rate of flow of electric charge, that is I equal to dq by dt, implies that dq equal to I dt, right? dq equal to I dt. Now this is what instantaneous current at a given instant. If you want to get average current in a given time interval, that is average current equal to total charge divided by, that is total charge upon total time to flow that charge, that is T, right? Now that is Q equal to, what is Q? See here from this relation dq equal I dt, it is saying that in every dt the point of charge is given by dq. In a time interval, in a large scale, what will you get? The total charge, that is integral dq, that is by taking summation of all small amounts, that is integral dq. Q in the sense integral dq divided by integral dt under limits within a time 0 to t, for example 0 to t, here also 0 to t. So that's what so average equal to integral 0 to t dq by dt, that is the dq means what? I dt. So therefore average current I equal, once again, integral 0 to t dq means what? I dt. So I dt by integral 0 to t dt. So this is what expression for average current. So average current I equal integral 0 to t I dt by integral 0 to t dt. In the same way, average kinetic energy and average potential energy in case of simple harmonic motion, right? So during the oscillation of the particle about x equal to 0 on either side, like that, kinetic energy as well as potential energy changes. Now what is the average value? Average, see from this relation, average kinetic energy equal to integral, see here, average kinetic energy equal to integral 0 to t y dt. Y means again kinetic energy. Kinetic energy into dt divided by integral 0 to t dt. Alright? See here also. Average current I equal to integral 0 to t I dt by integral 0 to dt. In the same way, average kinetic energy equal to integral 0 to t ke dt by integral 0 to t dt. Right? Now, what is the expression for kinetic energy? In the previous video, we came across that x equal to a sine omega, right? X equal to a sine omega, that is v equal to omega a into cos omega t, right? Now kinetic energy in the sense k equal to what? Of m v square, that is half into m into v square. V square in the sense omega square a square cos square omega t, that is omega square a square cos square omega t, that is v square means omega square a square cos square omega, right? So again, so that equal to half m omega square into a square cos square omega, that is half into m omega square in the sense k, that is one constant related to oscillation, that is k, something like force constant, that is half k a square cos square omega. So replace here. So average kinetic energy equal to integral 0 to t. K means of k a square cos square omega t into dt divided by integral 0 to t dt means t1. Integral dt means t, upper limit minus lower limit, that is t. So that is equal to here 1 by t is kept outside, of k square also constant, a means amplitude. So of k a square into integral 0 to t cos square omega t into dt. So we left with this relation, that is 1 by t into of k a square into integral 0 to t cos square omega t dt. We have a relation cos square theta equal to 1 minus cos 2 theta by 2. Sorry, 1 plus cos 2 theta by 2. That is 1 plus cos 2 omega t by 2 into dt. So here one more bracket. Why? Because of into 1 by 10 k square is common for entire term. That is integral. So that is 1 by t into of k a square into, I am splitting here 1 by 2 dt, that is 1 by 2 into integral dt 0 to t plus that is, otherwise 1 by t is kept common here, 1 by t is kept outside, that is 1 by 2 into, see 1 by 2 into 1 by 2, that is 1 by 4 here, that is 1 by 4. So 2 is kept outside, so we left with integral 0 to t 1 dt, that is dt, plus integral 0 to t cos 2 omega t dt, right? So one more square bracket, that is right. So that is 1 by t into 1 by 4 into k a square. Here integral 0 to dt means a t, small t, upper limit minus lower limit, that t minus 0 t, plus what is the average of cosine or sine within a time interval, that is 0. Why? Because on extending also you can get the same result. See here, suppose this is cosine function like that, so this is positive, this is positive, so 1/4 cycle, here 1/4 cycle, half cycle, so this is negative. So what is the average for this entire function, that is 0 within a time interval. So this is what t, this is what capital T. So within a time interval, the average of cosine or sine equal to 0. So otherwise, if you extend, you will get same result. So I am taking 0 directly. So we have t gets cancelled. That is, we left with 1/4 k a square. Otherwise, 1/4 k means m omega square. K means what here? M omega square into a square. So this is what average kinetic energy, expression for average kinetic energy, right? In the same way, one can find average potential energy for the same oscillating particle, average potential energy. So in the same way, average potential energy, that is, on the other hand, potential energy, this is what average kinetic, first part, that is kinetic energy. Second part, that is average potential energy equal to integral within a time interval. Within one oscillation, we are going to calculate or determine the average value of potential energy. That's why limits must be 0 to t. So within 0 to t, so u dt divided by integral dt 0 to t, like that. So integral 0 to t dt means 1 by t. Again 1 by t into, right? So integral 0 to t. What is u? U means what? What is expression for potential energy in the previous video? That is of k x square, of k x square. At a given position x from given position, what is the potential energy possessed by the particle? That is of k x square into dt, right? That is 1 by 2 is kept outside, 1 by 2t into k into integral x square 0 to t x square. What is x? Now itself we have written x means a sin omega t, a sin omega t square into dt. That is so 1 by t into of k into a square integral 0 to t sin square omega t into dt. Okay, so 1 by t multiplied by of k a square, so 1 by t into of k a square into again 0 to t. What is sin square theta? What is cos square theta here? 1 plus cos 2 theta by 2. Now what is sin square theta? We have one relation. 1 minus cos 2 theta by 2. 1 minus cos 2 theta. Theta means omega. Divided by 2 whole into dt. Here one more square bracket. Why? Because this is multiple of entire term. So integral 0 to t 1 minus, we have 1 minus cos 2 omega t by 2 into d dt. That is 1 by t into of k a square, right? So square bracket. Here 2 2 ja 4, otherwise directly 2 2 ja 4, 2 2 ja 4. That is we left with 1 dt, that is integral 0 to t. I am splitting 1 into dt minus integral 0 to t cos 2 omega t into dt, right? 2 omega t into dt. That is square bracket ends. Here 1 by t into 1 by 4 into k square integral 0 to capital T dt means again t minus t minus. Now what is the average value of cosine function or sine function within a time interval, otherwise over a long time, is equal to 0 directly, that is t minus. So that's why again t gets cancelled, left with 1/4 k a square, otherwise 1 by 4. K means what? Once again, k means m omega square. So that is what constant related to oscillation, which is usually known as restoring force constant, sometimes spring constant also while dealing with the springs. So 1 by 4 k means m omega square into a square. So this is what average potential energy. So from both results we came to know that the average potential energy, otherwise the average kinetic energy within a time interval, otherwise over a long time, is same. What is that value? 1/4 m omega square into a square. Here also 1/4 m omega square into a square. That's why within one oscillation, otherwise over a long time, right, when particle oscillates, then it possesses same value of average kinetic energy as well as average potential energy. Now on adding both, you will get one point. What is that point? So here, what is the result? So ultimately we have one result, that is average kinetic energy. See here, average kinetic energy within a time interval, otherwise within one oscillation, equal to average potential energy within the same oscillation, otherwise over a long time, is equal to, what is the value? 1/4 of m omega square into a square, otherwise 1/4 k square, that is 1/4 k a square, right? Okay, which is half of that of total mechanical energy. What is the total mechanical energy? That is of k a square, of m omega square a square. Okay, that is 1 by 2 of k a square. So 1 by, this can be written as half of the of k a square, of k s. That is average kinetic energy within time interval, within one time period, equal to average potential energy within one time period is equal to 1/4 m omega square a square, which is equal to half of the average of, what is this value? What is this value? Our total mechanical energy. Total mechanical energy, right? So half of the total mechanical energy. Half of the total mechanical energy, right? That is total mechanical energy can be written as 2 times. See, 1 by 2 becomes 2. I am taking this side. That is 2 times average of kinetic energy within 0 to t. Otherwise, 2 times average of potential energy within 0 to t. So this is what ultimate result. So total mechanical energy equal to 2 times average kinetic energy or 2 times average potential energy within one oscillation, right? Now finally, one numerical. One numerical. Suppose during simple harmonic motion, if x equal a by 2 is the position of the particle, then at that position compare its potential energy and kinetic energy with that of total mechanical energy, right? That is the given question. See here, a numerical. Suppose particle is going to oscillate like this about mean position. Now with the amplitude x equal to plus a here, x equal to minus a here, right? Suppose particle is somewhere here, x equal to a by 2, at x equal to a by 2. Now at x equal to a by 2, what is the potential energy? What is the potential energy? So find number 1, u of x by 2. Question mark. Number 2, u of, kinetic energy, ke at x by 2. Question mark. Right? A by 2. Here it is a by 2. Here also a by 2. X equal to a by 2. Find potential energy at x equal to a by 2. Question mark. Similarly, number 2, kinetic energy at x equal to a by 2. Question mark. Right? Now, what is the expression for potential energy? Not in average form. Usually, see the solution. What is the expression for potential energy? We know that U equal to, what is the total mechanical energy? Otherwise, total mechanical energy equal of K A square. Of K A square. Otherwise, of M omega square into A square. Right? Now, potential energy. Potential energy equal to of K, take x instead of A, that is of K x square. That is of K into x means what here? A by 2. At this position, what is the potential energy? So A by 2 whole square. That is A square by 4. That is 1 by 4 is kept outside. That is kept common. That is of K A square. So 1/4 of half K square means what? Total mechanical energy. Total mechanical energy. Right? So at a position x equal to half of the amplitude, the potential energy of the particle is 1/4 of the total mechanical energy. In the same way, question number 2, if it is 1/4 of total mechanical energy, what is the remaining amount? That is 3/4 of total mechanical energy. That will be the kinetic energy carried by the particle. So same can be proved like this. So kinetic energy form, that is of m v square. V means what? Omega into root over a square minus x square. So we have this relation also. Of m v square. V means omega into root over a square minus x square also. Why? Because you are given position at which we need to find kinetic energy. So we have to consider this expression. That is kinetic energy equal to of m omega square into a square minus x square. Right? So of into this what? M omega square means k of k into a square minus x square. That is of k into a square minus x means what here? Again x means a by 2. That is x square means a square by 4. A square by 4. That is a square minus a square by 4. That is 3/4 of a square. So of k into 3/4 of a square. That is 3/4 of See here 3 by 4 of half Ks. Half K is. That is 3/4 of half K square. Again, total mechanical energy. Total mechanical energy. So that's how at a position x equal to half of the amplitude, the potential energy carried by the simple harmonic oscillator equal to 1/4 of total mechanical energy. At the same position, the kinetic energy carried by the same particle is 3/4 of total mechanical energy. Right? So that's how potential energy and kinetic energy changes during its oscillation, but the total mechanical energy remains constant. Okay, friends. Thanks for watching. Bye.